All right, we are back with a continuation. This is now part 3 of our limits in calculus seminar. And just going to look at a couple examples here that are very similar to what we did in part 2, evaluating limits. So just remember from last time, when you're evaluating limits, you always want to first substitute. All right, that's the first strategy. You substitute the where the limit is approaching to, and I call this the plug and chug. You want to plug and chug. Okay, so let's see what happens. We're going to take this guy 3 and plug it in. So we have negative 3 over 3 squared take away 6. So that gets us negative 3 over 9, because 3 squared, 3 times 3, and subtract 6. And so now we get negative 3 over 3. And our answer to the limit question is negative 1. So we know negative 1 is the answer to that question. Okay, B now. We are going to plug in 9 into these guys. So plug and chug. Okay, we plugged. Now let's chug. So this is 3, and then 3 over 3. And we know this guy equals 1. And that's 4. So we get an answer of 16. Okay, so that's the plug and chug. All right, so next we are going to look at when the plug and chug doesn't work, because we are going to end up with some different situations. Okay, so always try plug and chug, but here we are plugging in infinity. So if we plug infinity in, you will see that we will get an answer of infinity over infinity. Because remember, infinity squares a very large number. So we say infinity, and again down here infinity. So when this happens, or situations when you plug in, you get 0 over 0. We call these in calculus indeterminates. So the indeterminate form. So this is called indeterminate form. Okay, so that's the indeterminate form. Okay, so there's a couple ways we can solve these situations. Now, first of all, I'm just going to go through a little scenario with you guys and see what the answer is, and then we'll take a shortcut. So first of all, well, we have to pick infinity, a number that's super large. Well, we can't put infinity in because it's not a number we can put into our calculator. But remember, you're approaching infinity. So if I pick a number, let's say 99,999, okay, and I square it. And I do the same thing down here, making a very large number because I'm approaching infinity. Well, if you type that into your calculator, you get a half. So that's the answer. Now, this takes a lot of punching in numbers into calculators. There is a shorter way of doing it. And it's L'Hopital. I call it the LH. And I'll get into this in more detail. The L'Hopital method. The L'Hopital method is you take the derivative of the top. So you take the ddx of the top, and you take the ddx of the bottom. Okay, so what's the derivative of x squared minus 5? Well, we know that is 2x. Okay? Well, if we take the derivative of the bottom, which is 2x squared plus 1, we get 4x. Okay? Now we know that simplifying, these x's cancel out, and 2 over 4 reduces to 1/2. So that's how we can get a little slicker and quicker. All right, so let's look at b. Now, if we plug in negative infinity into there, we're going to get negative infinity on top. And if we plug it into here, we get positive infinity. And then we plug it in there, we're going to get infinity. So we're probably going to get a negative infinity over negative infinity. So look at, we have another indeterminate form. So we are going to do L'Hopital again. So we got 15x squared is the derivative of the top. The bottom is 40x plus 10. Now, if we put the limit back in, you'll run into a problem here. Because watch. If we take this and plug it in there and there, we're back to that same scenario of infinity over negative infinity. All right, so we need to do L'Hopital one more step. So we get 30x over 4. Now, if we plug in infinity, we get negative infinity, because negative infinity times a positive is negative, over 4. So now this we can answer, because we have a very, very small number divided by a number. And so the answer to this question would be negative infinity.